My name is Mike Benson and I'm a solutions architect at Idea 11. We're an advanced AWS consulting partner in Australia. At Idea 11, our mission is to help Australian organisations undertake digital transformation using the cloud, from concept through to reality, turning innovation into the new standard. Today, I've put together a tutorial walkthrough which focuses on implementing authentication on an ASP.NET Core MVC web application using Amazon Cognito, OpenID Connect, and AWS Lambda. Most business applications require some form of authentication and authorization. It can be a challenging component to implement, especially handling sensitive data like profile information, passwords, and even federating identities. Amazon Cognito is a fantastic AWS service that handles all the undifferentiated heavy lifting to do with your app's users, so you don't have to. You don't have to worry about authentication, user profiles, user management, or ensuring that passwords are handled properly in your database. Amazon Cognito also handles federation so that you can authenticate users through social identity providers such as Facebook or Google, or log in with Amazon with SAML identity solutions, or by using your own identity system. If you previously implemented .NET MVC apps with authentication and you're looking to implement authentication in a serverless environment, you've come to the right place. There have been many iterations of the authentication and authorization layer over the last few years with ASP.NET MVC. With ASP.NET MVC Core, Microsoft have simplified the request pipeline, allowing you to plug in functionality if required, and this is referred to as the ASP.NET Core middleware. So today we're going to implement Amazon Cognito with AWS Lambda and API Gateway with OpenID Connect. This is one method of implementing authentication. It's not the only way. There are several other ways as well. We could use AWS API Gateway with the built-in Amazon Cognito authorization functionality. We could use the API Gateway custom authorizers, or we could use the AWS SDK directly with Amazon Cognito user pools. And there's a great blog post by Tim Moore and Mike Moraine on the AWS Blogs mobile blog to show you how to use C# with registering and authentication with Amazon Cognito. Microsoft and .NET are first-class citizens on AWS. The best part about Visual Studio with the AWS Toolkit is the extensive integration with AWS services. You can use the same Visual Studio solution without any complex configuration or additional effort to develop locally and on AWS Lambda. This allows you to get your project off the ground really fast and innovate rapidly. So to get started, install the Visual Studio 2017 community, which can be found at visualstudio.microsoft.com. And also install the AWS Toolkit for Visual Studio 2017. Visual Studio will make a new serverless .NET Core app. So go File, New Project. When you install the AWS Toolkit for Visual Studio, you'll get these extra options for AWS Lambda and some samples and that sort of thing. We want the AWS serverless application, .NET Core. So give it a name. I'm going to name mine Sparktail. Okay. We'll choose the ASP.NET Core web app blueprint. Base project has been set up for us automatically. We've got some sample pages in here. You can start developing straight away. When you're ready to test, just click on the Visual Studio Run button, and a local IIS web server will run your application. Now we have our ASP.NET Core web application running locally, so we can continue iterating and developing our app. Now we're ready to deploy. All we have to do is right-click on the project, go to Publish to AWS Lambda, Specify a stack name and click Publish. This will package up our Lambda function as a zip file with all of the resources that it needs to run the whole application. So what Publish to AWS Lambda does is create a CloudFormation template. This is the template contents. So as you can see, we have a serverless function. This is using the serverless application model. It's using the .NET Core 2.1 runtime, which is the latest .NET Core runtime supported by AWS at the time of this video. We've also got a proxy resource for API Gateway, which essentially just passes all of the requests through to be processed by this Lambda function. As you can see, our CloudFormation template has been successfully created. We now have an AWS serverless URL. We can just click on that. And now our ASP.NET Core web application is running in AWS Lambda. Now that we've got our serverless application deployed and publicly accessible, I've chosen to use a couple of other AWS services to customize the web application for this tutorial. You can see this domain that's been provided by API Gateway. It's not very memorable. I'm going to create a custom API Gateway domain so that we can easily access our web application at www.sparktail.com.au. I also want security for this web application. So I've created a public SSL certificate that's been generated in the US East 1 North Virginia region using the AWS Certificate Manager. I've created a Route 53 hosted zone for this domain as well. I will be creating a www record and pointing that to our API Gateway application. So to do this, we'll click on API Gateway, open up the API Gateway console, and click on Custom Domain Names, and then click on the Create Custom Domain Name button. Fill out the domain name that the application should be associated to, and then you'll be presented with a target domain name, which is actually a CloudFront distribution that fronts the API Gateway. We can copy this domain name and go to Route 53. Now we have associated this domain name with our CloudFront distribution, which is allocated to our API Gateway and Lambda project. In API Gateway, we need to map the base path to our production app. So we click on Edit, Add a Mapping, choose our Lambda application, and it's deployed in the prod. We can click Save. So now when we go to www.sparktail.com.au, it will invoke the Sparktail API Gateway in the prod stage. Now when we go to Sparktail, we are presented with our serverless web app. Now we want to add some security to our app. Back in our project, we'll make a new page. Let's go Razor page. I'll call it secure. Now we've got a page that's been created and also a page model. The page model is the code that gets executed behind the page. And we can see the actual page here is displaying the word secure. We'll make a link to our secure page. Now we can see the word secure in our menu item. If we click on that page, we see our secure page. Our goal is to implement Amazon Cognito so that when we click on this secure page, it should prompt us for credentials and a login before we can access this page. So next we'll configure Amazon Cognito. Open up the AWS console and navigate to the Amazon Cognito service. You'll notice that there are two buttons on the start page for Amazon Cognito: user pools and identity pools. A user pool is essentially a user directory where you can sign into your web app. User pools provide sign up and sign in services, built-in customizable web interface to actually sign in. It provides user management and user profiles, etc. Identity pools are federated identities which can allow us to authenticate and obtain limited privileged temporary AWS credentials to access AWS services or to access resources through API Gateway. For this tutorial, we're going to have users who are part of a user directory. So in this case, we're wanting to create a user pool. Go ahead and choose user pools. Go create a user pool, specify a pool name. Next, we'll be prompted to configure the user pool. Amazon Cognito provides a whole lot of customization right out of the box, and it's really easy to make these customizations. I'm going to step through some of the options and make adjustments to suit my requirements. I'm going to allow users to sign in with a username rather than a password or an email address, so I'm going to leave this option checked. Attributes are essentially user profile data. These attributes are automatically included as part of a user profile. You can mark them as required if needed, or you can add your own custom attributes. At the moment, I don't need any custom attributes, and I only require email as a mandatory field, so I'll click Next Step. Here you can specify password complexity policies to ensure that your users are using secure passwords. I'm going to leave this as is. The default is secure enough for this tutorial. I don't want users to sign themselves up. Only Sparktail employees should have access, and only Sparktail administrators should be able to create users. So I'll change this to only allow administrators to create users. Users will have 7 days to log in before their account expires. MFA. MFA is a great piece of functionality. This provides additional security on top of your authentication. Highly recommend that you enable this for production purposes. There is a small cost involved with sending SMS messages, so be aware of that. It's definitely worth enabling. However, for this tutorial, I won't enable MFA, so I'll leave this off.
You can require verification of emails or phone numbers. This also enables the ability to provide automatic forgotten my password reset options. I won't enable this for this tutorial, but it's probably a good idea for production purposes. So I'll untick that. I won't be sending SMS messages or emails, so I'll just leave that as is. Tags. Amazon Cognito supports tagging, which can provide insight into your AWS build. I won't be entering any tags at this stage. You can optionally remember users' devices. I won't at this stage. App clients. I'll come back to this configuration. This is how we link our user pool to our ASP.NET Core MVC serverless app so that we can interact with the Cognito service. So I'll come back to this one. Triggers. Cognito provides fine-grained control over the whole authentication workflow. Cognito allows us to hook into events and run custom AWS Lambda functions to provide additional functionality or steps in our workflow. This can also be really helpful for migrating users from a legacy authentication system to provide them extra information on how to log in or extra emails or other information. But I'll leave these as is for now, and then we'll go ahead and go next step. I'm happy with these options. Now we have our user pool that's been created, and we've been provided with a pool ID. Next, we want to connect our user pool to our ASP.NET Core MVC serverless app. The next thing to do is to specify a domain name for the Cognito hosted UI for the sign in page. So under app integration, go to domain name, specify a domain name. Availability, available, go save. So now we have our Cognito domain set up. The next thing that we need to do is to create our app client. So click on App Clients under General Settings, add an app client. We want to generate a client secret. This is what allows us to call the Cognito APIs. We'll just go create app client. Now you can see here that we've been provided with a client ID and an app secret. Next, we want to specify the app client settings. So go to app client settings under app integration in the left-hand menu. We want to enable the Cognito user pool as the enabled identity provider because that's the user directory that we're going to be storing our user data. We want to specify the sign in and sign out URLs. OpenID Connect uses a special resource to facilitate the message handshaking for OpenID Connect, and that is signin-OIDC. For the sign out URL, we want to specify just the homepage of the application. Under OAuth, we want to enable the code grant as well as implicit grant, and we want to allow email, OpenID, and the profile scopes. You can customize these to the scopes that you want to provide your application, but these are the ones that I'm going to enable. Go ahead and go save changes. The last thing that we need to do in the Cognito console is to make a user. So we'll go to users and groups, create user. I'm going to call mine Mike. I want to send an email. Specify an email because that field we set as a required field. We will mark it as verified and we'll go create. So now we have our user, we can get started at making the changes to our code. So what we'll do next is open up Visual Studio, go to the startup.cs file. The startup.cs file is a configuration file that configures the ASP.NET Core MVC middleware components. So to enable authentication, we just need to add a simple line here to use authentication. It's in the configure method. And now we need to configure the actual authentication service. So under configure services, we want to specify that we want to add configuration. So here you can see that I've just added services.add authentication with some options, with the default challenge scheme of cookie default authentication defaults. So we want to use cookies to store the user's session, so that if we close off the browser and open it back up again and visit the site, that we're still logged in. And we want to set the default challenge scheme to OpenID Connect. This is authenticating against Cognito via OpenID Connect. You can see that we've added the cookie and we've also added the OpenID Connect service. We've added some options here, so we're specifying that the response type should be code, and that we're specifying the metadata address, the client ID, and the client secret. These have been offloaded into variables that will load from a configuration file. This will make it a lot easier to work between different environments, such as production, test, dev. We've also added a special event here. So when we log out of the application, that will be redirected to Cognito, passing in the client ID, as well as the logout URL that's been specified in the client's app settings in the Cognito console. You can see this top section here, these few lines. What this is doing is loading the client secret, the client ID, metadata address, logout URL, and the base URL from the configuration file. The configuration file is in app settings. So if we open up the app settings.json, you can see here that I've specified Amazon Cognito. Client secret is the client secret that we were provided from the Amazon Cognito app client secret. The same with the client ID. The metadata address is generally the same between the different user pools. However, we need to specify the specific user pool ID within the URL here. We also need to specify the logout URL. This is the Cognito domain prefix and the Cognito domain that we've specified within the app client, followed by /logout. This is the logout endpoint. and the base URL is set to the URL that we're going to be using for when we are logging out. We'll need to be redirected to sparktail.com.au. And that's pretty much all of the configuration that we need to do. The last step in the process is to enable authentication on a particular page. So now we can open up our secure page, specifically the secure code behind, and we need to add the authorize attribute to the class. What this does is when we browse to this page, it will require authentication. We'll go ahead, right click, publish to AWS Lambda. We'll go publish. Now when we browse to our serverless web application at sparktail.com.au and click on the secure page, we are redirected to the Amazon Cognito login screen, where we can log in with the credentials that we specified. And we are redirected back to our secure page. And it's that simple to add authentication to your ASP.NET Core MVC web application running in AWS Lambda. Thanks for watching.